This is joint work with Ken Benoit, who's just there and who will field all hard questions. I'm going to talk about human validation of latent trait scaling from textual data, but before I do that, I'd like to say some words about the title of the session, just to sort of put this particular sort of work in context. First of all, let me say something about the political information that we might be extracting from legislative text. So if you were to turn on parliamentary television, let's say in Britain or America, you would see these kinds of things happening. People proposing legislation, constituency stuff coming up, and people spanking the government for bad things they've done. We can kind of boil down all of this in the way we're looking at legislative text into two things happening in legislatures. We can think about learning about the policy agenda, what's a topic worth doing politics about, and we can think about position taking, people standing up or parties expressing their position on particular policy issues. In this talk, we are interested in the second part, so how to take and how to make a position. When thinking about these actions in legislatures, then we can ask why speech, and it's useful to briefly say why speech is useful, is helpful for this, rather than all the other information that you could possibly be using. So a natural thing to do in America and a very unnatural thing to do in party democracies in Europe is to look at roll call votes to figure out who's where on various issues, see which way they voted. These are potentially slightly biased and certainly uninformative about individuals when there's party discipline. On the other hand, we might look at party manifestos to get a more nuanced view about at least what parties think their positions are on various issues. But then we only get this reading every 5 years or so, and that's not very good. So finally, we could look at what they spend their days talking about, legislative speech. So the speeches. Ideally, that's more expressive. There's certainly lots of it. Lots of people get to talk, and hopefully there isn't too much constraint on what they get to talk about. When we think about taking learning about positions from text, then we need a model. And I'm going to work with a class of statistical so-called spatial models which extract positions from text. And the basic intuition for these models is at the top there. If you want to know what position is being taken or understood, then you need to consider the relative emphasis of words, topics, or issues. Here we're going to think of the things that we can generate relative emphasis over as words. I say this more often, I say that less often. This is obviously a count data problem, and the sort of models we might immediately leap to here are things that look like this. This is an association model. The raw data here is C there. That is the number of times Mr. I said the word J over our period of time. That's not quite a log linear model. You'll see an independence model here and then some residuals deconstructed into the position that Mr. I is taking and the effect that Mr. I's position has on the word count. So if we have a large beta weight there, then as he decides to express a more right-wing opinion, then the count of word J lurches up or down. There's the basic story. These models are sufficiently useful that they're persistently reinvented. You can see a couple of versions down there, going all the way back to 1979. We could equally have done the whole thing in French and worked with correspondence analysis, which is a very similar model. Again, we're interested in this ideal point position being taken on the basis of the words. Slightly different least squares version of the first model. Again, persistently reinvented because it's very useful. What we're interested in here is, do we get good estimates of political position, the red part there, when we fit these models? Well, that will depend on whether the model, whether the assumptions these models make are reasonable, and here we're going to break down the assumptions that scaling models make into three broad groupings. First of all, we are going to assume, these models do assume there is only one dimension that people are taking a position on. Unidimensionality here. So it's, let's say, how warmly we feel towards further integration with the European Union or a traditional redistributive left-right or something like that, but there's only one of them. The second assumption we're going to make is essentially that we have Poisson distributed words. So we have a particular statistical model for how words turn up such that its rate is driven by the ideal point being expressed by the speaker. It has certain statistical properties, and it has this rather unfortunate substantive one which says that words are generated independently. And for anyone who speaks grammatically, which is all of you, that's probably not true. We're also going to assume local independence, and what this means substantively here is that when someone stands up in a legislature, all they're doing is taking a position, and every other bit of variation in their words is actually just noise, essentially. Now, these things are strikingly unlikely if you know anything about linguistics. Nevertheless, we can actually do reasonably well with them. So here's 15 years of the German party system. 1990 there, 2005 here, ideal points and parties. FDP is down here at the bottom, the most right-wing party. And we can chart over time where we think these parties are going on the basis of manifestos. You will notice perhaps two things about this. First, these make sense from a German politics perspective, but secondly, they also have error bars. How useful, nice statistical models. So we have a measure of uncertainty, and you'll notice that it's very, very small. An alarmingly overconfident model, we might suggest. How overconfident is that? Well, we're interested in knowing not only do we get the positions right, but do we get the appropriate level of uncertainty. So, and we can ask these questions separately. Here's a quote from the noted methodologist Thomas Satz. We are concerned here about, first of all, whether the model is right, whether the positions that we get out of this are reasonable, but also whether we are appropriately certain or uncertain. In Satz's terms, we are now having neurotic fears about whether our model is psychotic, if you've read that. Right. What is an appropriate level of certainty then? If we have this model, how would we know when we're being appropriately uncertain? Or how would we validate the intuition that that model is over-certain about German party positions? Well, if we want a good measure of uncertainty, and this is a general observation for such models, we should be able to answer the question there. How could this speech have gone differently while still making the same point? If you were to force Groundhog Day style the legislator to stand up again and give it again, the exact same position, it wouldn't come out quite the same way each time, but nevertheless the position would be the same. How variable could the words have been while still holding the position? If we know that, then we know how sure we can be what the original position is. It's a basic intuition there. So we can, in the context of these models, we can be uncertain. We can represent our uncertainty in various ways. We can assume, well, my first intuition for all such models is to put priors on everything, run my Markov chain Monte Carlo for 2 weeks, and come back and see what happens. That's the Bayesian approach, which assumes that the model is true. So everything, all those three assumptions are correct. We can, in a more traditional framework, fit these things by maximum likelihood, which we also assume the model is correct. And with a little bit of algebraic gymnastics, we also assume that that we've got well-estimated word parameters. But finally, more interestingly for us, we can use this bootstrap method which says, look, I think position taking is going on, but all that Poisson assumption, that's kind of unreasonable. So I'm just going to leave it open what the sort of variation is. Let me say a few more words about bootstrapping text. People don't do it very often. We've done it a lot, so let's see. The intuition here is that if you want to know how the speech would have gone while representing the same position, you rewrite it and have a look. So all bootstrapping methods effectively rewrite the same speech multiple times on various assumptions and then see how variable the estimates are. A simple one here is to say, I like my model, and therefore I'm going to sample data as if it were true. And that will give me a measure of uncertainty. Not a very good one, because we don't trust the model anyway. We could, on the other hand, assume that words just occur in some sort of Poisson processy way, get our statistical routines out and resample the words. Still not a great speech. On the other hand, we could imagine that we're literally rewriting the speech. So we line all the sentences up in a legislative speech, and then we resample from them. So that's pretty much what I could have said but didn't. I say some things more often. I say other sentences not at all. And the variation across there is a possible speech. And it's the same here with blocking. Blocking is that situation where, blocking is that situation where you kind of back up and repeat, and you get the same effect as with the sentences with pauses and repeats. Right. Lots of different ways to be uncertain about position. Obvious question, which of them is reasonable? So the only way to find out whether they're reasonable is to do some qualitative analysis here, because we can't just live in a quantitative world altogether. So what that means here is, well, obviously what that means here is asking PhD students and postdocs to do it for us. So take 18 PhDs and postdocs from the London School of Economics and from Trinity College Dublin, and ask them, okay guys, read these 14 speeches and tell us where all the speakers are. A little background on the speeches. The particular case we're looking at here is the 2010 Irish budget, a particularly fierce budget in which the government explains how everything's going to be cut and the opposition objects vigorously. In this particular setup, we have in government Fianna Fáil and the Greens, and in opposition, these three parties over here, Fine Gael, Labour and Sinn Féin, and we'll see them lining themselves up on what is essentially one direction. How much do you hate this budget? So let's return to our two questions. There is, do we get back human positions, and are we appropriately uncertain? Well, that's what humans think's going on. Parties here, individual speakers here, and then a normalized position estimate. So there's government, there's opposition, and there's crazy people on the left. If we ask these scaling models to do the same estimate, we can compare and contrast. So in this case, indeed, we have government over here, which this model thinks has more variation in it than our respondents think. We have Fine Gael and we have Labour. And curiously, these extremists seem to have wandered to the centre on the basis of our scaling model. So, an interesting bit of variation there. Right. So let's think about doubting the model first, then wonder about the uncertainty later. So what we have shown is that this class of models does distinguish government and opposition. It pretty much lines up everybody in the order that we think this budget's going on. So we are extracting, in some sense, the position, with the exception of Sinn Féin, this party that moved. We see a bit more variation in some places. Apparently, we get better party information than we do speaker information, either due to party discipline or because this model is not that good. So that's the ideal points. What about uncertainty? What's a reasonable way to be uncertain? Well, here's 5 ways to be uncertain. On the bottom, sorry, a little bit of a complicated thing here, there's where the humans decided to put each party. And if the model has just as much uncertainty as our humans, then there should be a nice neat line on 0 there, the difference between the model and the humans. This is a little bit spiky because each of these spikes is a party position. So you can see that Sinn Féin over there and Greens over here. Let's start at the bottom with the black. That's the analytical standard errors, assuming the model is true. The parametric bootstrap also assumes the model is true. That's the red one. Wildly overconfident, right? At least twice as confident as they really ought to be. So our intuition that this model is very, very certain is indeed reasonable. It is too certain. Our bootstrap methods are up here. Some of them are in fact more uncertain than humans, which is perhaps not unreasonable. Our word bootstrap is this blue one here, which more or less runs along the 0 line. So that's the closest we can get in this framework to being about as uncertain as our humans are. Right. About the uncertainty, well, we got model-based uncertainty, and that's wrong. So basically, for this class of models, you just shouldn't use it. The bootstrap stuff kind of works best when it's words. What you might have noticed about that is also that there's a rather wide variation in standard errors here. There's a large amount of uncertainty. Those are also the positions that the model got wrong, so it's appropriately uncertain about things that it got wrong. This, I claim, is a good thing. So let me make some quick conclusions, and then I will ask the chair something else. Right, we make strong statistical model assumptions in these models. They're kind of crazy, right? We sort of know they're false. But actually, that doesn't prevent effective extraction of positions. There's no kind of information being added here. The uncertainty measures that come with the model are a little bit too confident, and so, but on the other hand, we can fix them. But the main kind of meta point for all of this is that we wouldn't know all this had we not done a qualitative validation of these quantitative measures. So we could not skip that stage. Important things that you won't see probably on anybody else's slide. Perhaps you'd like to do this yourself. That's on RForge for those people who use R. That's already built into R. You can have our code if you'd like it, but you do have to find your own PhD students.